Welcome once more. Today we're going to be talking about primitive types in Rust. So before we get into that, we're going to introduce a basic method for us to a basic way for us to introduce various standard type, various functions, resources, structures from the standard library of Rust, and we do that using what I've just written up here. Oh, okay. So we see that we introduce one new keyword called the use keyword, and what it does is it just tells us that we want to use some method from some location. That location is from the standard library under the main module, and we are getting the size of method, right? The size of function. Now with that in place, we can easily use size of function anywhere in our program right now, and we'll be exploring the various sizes of types using this method or using this function, sorry. From OOP, object-oriented programming, I keep saying methods. Okay, so the first type we're looking at is the integer type we have been working with for a long time now. And an example is what we've just written here. Let I equals 21. Ross immediately assigns it a type i32, right? And this i32 means that it's 32 bits. From this little table I drew here as a comment, we see that i32 corresponds to a certain u32, which I'm going to explain later, which corresponds to 32 bits, and that corresponds to 4 bytes. Now, what do we mean by byte, right? What does that exactly mean? 1 byte is equal to 8 bits of memory. So when we say 2 bytes, we mean 16 bits. 16 bits of memory. Is that okay? And we see that these 2 bytes here correspond to the same 16 bits, and I'm not really going to explain this because it's a computer science lecture, but what it just means that these different bytes that we have, we can store different sizes of values of data in memory when we represent them this way. So by i32 we see that we can store data that has up to 4 bytes of memory. So then what do we mean? If we introduce a different type here, i8 to this variable, we see that it's assigned the value 21. There's no problem because if we run this program, this value 21 falls within the range for all values that can be stored by an 8-bit signed integer type. So what does that mean? If we want to get the values that can be able to be stored within that range, we just look at this simple formula I have here. Negative 2 to the power n minus 1 up to 2 to the power n minus 1, all that minus 1. And with this, for the i8, what we can be able to store is negative 128 to 127. Meaning that if we try to assign any values that are out of this range, then we are going to get an error presented to us. For example, if we try to say 128, which is just 1 greater than 127, we see here that they say literal out of range for i8. If we, in fact, VS Code even shows us the range for i8, so we need to make sure that the value stays within that range, and that's because we have said that this type is i8, meaning that it can only store up to 1 byte of memory. Anything falls out of that range, don't store. This can be applied to all these other types, and they have their own ranges which can just be calculated by replacing, for example, 16 with n that we have in this our formula here. By the way, if you notice that there is some sort of a problem with this formula, then please mention in the comments and we're going to rectify it. Okay, now going ahead, we are also going to explore U8, U16 right up to U128, and this simply just means an unsigned type. If we change this from i8 to u8, we now see that we can store 128, and that's because we are no longer from negative 128 to 127. We are now from I never wrote the formula for that. We are now from 0 to 2 to the power, I think it's 2 to the power 2n minus 1, I suppose. Okay, with that, then because we have simply just added up the range that we have for all the values which were negative in this range from this all over to this, so we can store values up to 2 I think it's up to 256. Yes, we cannot store 256. That's because it's above the range. So the highest number we can store in this range is 255. And if we try to give 256, we see the error out of range because it's from 0 to 255. If you also try to store -1, it's less than 0, it shows an error. Is that okay? So now with that in mind, let's just give some random number here and let's go ahead. We'll now try to explore the size of function and see what it returns to us anytime we call it. So let's just say print line, let size of type be equal to size of, and we're going to pass it a type here u8. Okay, so now with that we're going to print out the size of this type of errors. We're going to print out the size of this type in our print line function here, given size of type, and cut this out so we can test this. Okay, before we even run this, let's look at something here. We have a new type introduced to us, usize. I'm going to explain after running. Now the size of u8 is 1, and this one here simply means 1 byte. If we change this from u8 to u16, it's going to immediately correspond to what we have here in our table, 2 bytes. And let's change to 128. If it doesn't correspond, oh goodness, 16 bytes. Perfect. So with that, we see that we have now one function which we can just use to get the size of our various data types in Rust, and that's pretty much what that function does. So going further, let's talk about usize. Based on your computer, usize is going to have a different value. If I'm using a 32-bit computer, then usize should have the value 4 because it represents 4 bytes. If I'm using 64-bit, it should be 8. So let's just have usize here, and I'm running this 8. So that means I'm using a 64-bit computer. So it gets the architecture of your computer to determine what size it should use to represent for usize. That's what Rust does. And we'll be looking at usize when going further with more loops and arrays and so on, but let's not talk about that now. So now we have been able to see different number types in Rust. That's i8, I up to i28. There's another type, f16, and there's no f32, Jesus, and f64. So that's now similar to i32 and i64, but with now the ability for it to store floating point numbers. And the reason for that is because let num be equal to 32.6, and let's force num to have the type i32. That's not possible because we expected an i32, that's an integer, but we are getting a floating point number. So floating point numbers now can be either represented with f32 or, for a larger range, f64. However, Rust just automatically gives it f64 because that's larger than f32, and it's kind of a safer way for it to represent floating point numbers. Now with that, we can say we have completed looking at primitive numbers, or number types that are primitive types in Rust. Another thing we are going to look at is character types, and an example of a character, like the first character of my first name. Let's just give the name C to be equal to E, right? So this is the char, that's what we call it in Rust, and the size of char should be, size of char is 4, so that's 4 bytes. We use 4 bytes to represent one character in Rust. So if you have 10 characters, you know that you're going to be using 40 bytes, I guess. Okay, these characters have Rust has a way which is used to store these characters, and the way it stores that it means that one character like E is different from, let's name this other one C upper, is different from this. Obviously they are not the same thing. So if you maybe try to do something like this, C equals C upper, you should expect to see false. Okay, so the character type in Rust, we just use them to store one character at a time, and there's really nothing very special about it. But there are some times when you might need to use single character types in Rust, but till then we're just going to end with that for now. And then going further, the only other type we haven't mentioned, the only other basic data type we haven't mentioned is for example, which is a boolean. But we already had a video who really dedicated to talking about booleans, so we assume knowledge on that for now. So with that in mind, we have also seen strings, we have seen numbers, we have seen booleans, we have seen characters. You can see we have seen basic data types in Rust. And when we look at the data type, what we should think of is not that it stores a number. We should rather look at it to be a description for Rust to allocate a particular size or a particular amount or a particular section of memory to store a value, and the value has to be a certain kind of way. You have a way for you to represent it, because something like this doesn't get stored in the computer as a C. You won't open your RAM and see a certain C hanging or floating somewhere because you did this. It gets stored as zeros and ones, as we always like to talk, and because it gets stored that way, there must be a way Rust represents this, and it does that using this type char. Same for bool, same for i8, u8, f32, whatever. So with that said, we can say that we have completed this. One simple exercise you can just try out using this size of function is check the size of the string type, check the size of the boolean type, check the size of the f, the other types you haven't mentioned here, and try to see if you can check the type of something you've created yourself. Thank you very much, guys. See you in the next video.